Without further ado, let's welcome our next speaker, Jayant, to talk about why it's very hard to compete with TradFi, with DeFi, and what we can do to make that a much better experience. So please give Jayant a big round of applause.
Thank you, Karthik. Hey everyone, my name is Jayant. I am the CTO and co-founder of Duro Labs, and we are building Pyth Network. If you're not familiar with Pyth Network, I'll tell you a little bit more about it a little bit later in the talk. And the title of this talk is something like, what's it gonna take for DeFi to compete with TradFi, or why can't DeFi compete with TradFi? And I think the answer to this question is actually very simple, which is that, well, DeFi sucks. So, now you know the answer. Thank you for coming to my talk. But seriously, I do think that as builders in the space, we need to recognize that there are a lot of problems with DeFi and that the actual experience of using DeFi today is not going to meet the needs of the vast majority of users. And that is fundamentally why DeFi is not replacing TradFi. And just to drill down on this a little bit, I want to do a comparison of the experience for users using DeFi versus TradFi. And look, this analysis is not meant to say that there aren't problems with TradFi. I mean, try opening a bank account or moving countries, or God forbid you have a business and you need to open a business bank account. There are a ton of problems with the traditional finance system. However, those are not problems that people encounter every day. Those are things that you hit once in a while, maybe once in a year. You get really frustrated, but then you kind of forget about it. And I think it's important to realize that for the vast majority of use cases, the traditional finance system is actually pretty good. And so I want to think about that in terms of 3 dimensions, which are, first of all, speed. The traditional finance system is actually pretty fast. If you want to place an order or buy something on Robinhood or a platform like Charles Schwab, your trades will settle very quickly, less than a second. It's just like using a normal website, so it's a pretty friction-free experience. The whole process is pretty efficient. The second one is cost. So on all of these platforms, you have essentially zero cost trading, right? Market makers with payment for order flow enable zero cost trading. The liquidity is really good. It's very efficient to use the traditional finance system. The third thing I will say is trust. And look, I know DeFi is all about eliminating trust in third parties, but in reality, the banks, the brokers are pretty trustworthy. They've been around for a long time. I'm sure all of you have money in these places. I doubt that any of you are worried about losing that money right now. So from a trust perspective, the system also works pretty well. And that is really what we're competing with in DeFi, right? It's a system that's actually pretty good. And just let's see how DeFi stacks up against that traditional finance system. So for DeFi, first of all, let's talk about speed. Depending on your blockchain, things are going to settle in a couple seconds. That's not counting all of the other, messing around you did with your ledger to sign the transaction or whatever. That's easily going to add a minute, right? So it's a much slower process to interact with DeFi than it is to interact with TradFi. The second one was cost. So DeFi is much more expensive than TradFi in a couple different ways. Obviously, gas costs will be salient to everybody here. You've all had to pay for gas costs. Those are coming down as we improve the technology. But there are other costs like liquidity and slippage, which are just worse in DeFi than they are in TradFi. And this makes transacting much more expensive. The third thing is trust. I'm pretty sure that, some of you probably have your money in DeFi protocols, and you're probably worried about losing it, right? There's a lot of hack risks. There's a lot of trust issues at lower levels of the stack with things like infrastructure that could actually cause you to lose all your money. So just based on this comparison, I think it's safe to say that DeFi is not as good as TradFi for the vast majority of people's use cases. And to give you a preview of where I'm going with this, at Pyth, what we're trying to do is we're trying to build infrastructure that enables decentralized finance applications to compete with TradFi applications. So we're trying to kind of bridge that gap over here. And I'll talk a bit about how we're doing that in a minute. And the reason that we're doing this is actually, when we started building Pyth, we sat down and we really asked this question, which is, what is preventing DeFi from competing with TradFi? What are the actual problems? And the thing that we realized is that when you're in one of these situations like the blockchain, which is sort of a new paradigm for building applications, you really need to end up in a situation where the new, the way this works is basically, look, there's a new paradigm. Let's say it's the internet. There will be someone who is solving a problem using the internet as technology, and there will be an incumbent who's solving the problem in an old-fashioned way. And in order for people to really shift from the old paradigm to the new paradigm needs to offer them a solution that is better in some respects and no worse than their existing solution in all other dimensions, right? This makes it much easier to sell someone on making the jump. And this is also when it becomes obvious to people that this is the right way to do things. It's much, much, much harder to get people to transition when they're gonna get some benefits, but they're also gonna lose something in the process, right? Just psychologically, that is difficult. And so we can actually look at some examples of this. So let's look at an example from the internet. I think this is another example of a classic kind of paradigm shift in how people build applications. And the thing that the internet really brought to the table is zero marginal cost distribution. So this means Amazon could offer an effectively infinite number of products for sale, right? They can have an infinite number of pages in their catalog, right? And that's a benefit. That's something that users would want. But if you go back in time to, say, 1996 and try to do a comparison between Amazon and the Sears catalog actually looks pretty good. So, with the Sears catalog, let's say you're looking for something to find. There's like 10 pictures per page. You can flip through pretty quickly, maybe a second per page. It's pretty easy to go through that and find things and buy them. Whereas with Amazon, on a 56 KB modem, it would take you about 2 minutes to load 10 pictures. I think it'd be pretty hard in 1996 for people to think that this really slow website is the future of e-commerce, okay? So this is, again, another paradigm shift. But the interesting thing about these paradigm shifts is as the infrastructure that powers these applications improves, adoption kind of grows along with that. So here's a graph that I have that shows the adoption of Amazon as a function of time. And I've marked on here, some of the infrastructural improvements that have kind of, where they came along in that journey. And I think, you can ask this question for yourself, but you can ask, when did it become obvious to you that Amazon and e-commerce were really the new paradigm for doing shopping? And for me, I think that was somewhere in the mid-2000s, and I think it coincides pretty closely to when broadband internet became widely available. Because with broadband internet, you could actually browse the Amazon catalog. It didn't feel like a slow and clunky experience, and then you could get the benefits of the added selection, right? So that's kind of the place and time when the experience was no worse from like a browsing perspective for Amazon. And so hopefully this framework for thinking about things makes sense to you. And I think we can do kind of a similar analysis for blockchain. So blockchains do bring a fundamental improvement to, what do I call it? I forgot what I called it. But anyway, they bring a fundamental improvement to the technology, which is they enable programmable trust. It is a setting where the people using the system trust the incentives of the system to ensure that it operates correctly versus trusting some, middleman, effectively, like you would in Web 2. And, this adds security and things like that, which are properties that people value, right? So there are real values to this innovation. And I think this is actually the reason why a lot of us are here today, is because we're excited about this vision of the future. The thing about it, though, is that we have not yet reached the point in time where the infrastructure that powers Web3 is good enough to compete with the traditional finance system. So to do that, let's do a comparison of, say, like DeFi versus Charles Schwab, right? With Charles Schwab, you have something like 300 millisecond latencies on your trades. You have zero commissions. This is much better than what you're getting with your DeFi apps today. However, I think if you look at, again, an adoption curve as a function of the infrastructure, you can see how as infrastructure is improving, it's improving the experience for all the applications. And we're also seeing sort of concurrent adoption in wallets and things like that. So, we're on a similar sort of paradigm shift. The growth curves are all going, but we still need to work on the infrastructure in order to really enable that next generation of applications, right? I think we're getting better, but we're definitely not there yet to the point where we're really going to start competing with TradFi. So what we are doing at Pyth Network is that we're trying to build DeFi infrastructure that enables applications to be supercharged and really compete with their traditional finance equivalents. And we think about that on these three dimensions of trust, speed, and cost. And when thinking about that, we've thought about a number of different products and solutions that we can release that kind of help applications in different areas. And so I want to talk a little bit about some of those, and then I'll talk a little bit about places where you can see how these infrastructural improvements are actually leading to new kinds of applications. So the first thing that Pyth released, which is sort of the flagship product, are price feeds. These provide prices for something like 500 assets on 75 blockchains, different environments, those kinds of things. And when we were approaching this problem in 2021, the reason we were attracted to this was because it was clear to us as people with a financial background that market data would be a really critical component of any sort of DeFi solution. Data is critical to all of finance. If you've ever worked at a trading firm, you will know this. And the other thing that we realized is that, look, this is an oracle, right? It's trying to bring state from the off-chain world on-chain. But we realized that this problem, this type of oracle problem, really needs a specialized solution in order to be competitive. And the reason for that is that market data is highly latency sensitive. It is most valuable when it is first created, and then the value decays as a function of time. And it decays pretty quickly. So if you have ever Googled a stock price, all of that data that you're seeing that's publicly available is delayed. And you're effectively getting the free version of the data that doesn't have any value left. If you actually want the valuable data, you have to go to someone like NASDAQ and pay them for a real-time subscription. And these subscription costs tens or hundreds of millions of dollars. So NASDAQ and these other exchanges make something like $7 billion a year selling market data to hedge funds and other people who are latency sensitive. So it's a very big business. And we wanted to basically bring that type of market data onto the blockchain. The first obstacle that we found is that the blockchain is not a good spot for businesses like NASDAQ because their whole business is based on selling a subscription where you can't resell the data, right? It's all about hiding the data. Whereas if you want to put it on the blockchain, it all becomes, world readable, right? So it breaks their business model. So what we did instead is we found other parties to participate in the protocol, like hedge funds and market makers, who have access to really high quality data, but hadn't viewed that data as a source of revenue, right? It's sort of a byproduct of their operations. And by bringing these participants into the protocol, we found a really low latency and high accuracy source of market data that we could broadcast to the world. And we combined this with a pay-per-use model where people can pull the prices onto the blockchain and pay every time they do so. And this combination has really enabled the system to scale to the 500 feeds and the 70 blockchains and all those things today. So I'll talk a little bit more about these price feeds. I think this is the product that we've had around the longest and has actually enabled the most kinds of applications. So I'll talk about that at the end. But I want to talk about the other products first. So, okay, skip that. The second product that we launched is on-chain random numbers. So this is kind of an analogous situation to the market data, except it's sort of for gaming. Every time you're building a game, you have a question about, do you want to trust the publisher of the game, or do you really want to have a secure protocol for generating the random numbers so that everybody using it can feel confident in the randomness, right? That your pack of cards was generated fairly and those kinds of things. And when we were looking at this problem, we thought that the existing solutions didn't really meet the speed and cost characteristics that people would want. They're a little bit complicated, they require complicated cryptography, and this is just hard to do on the blockchain. So what we ended up doing is we ended up launching a new protocol, which is powered by, it's sort of a version of a very classic cryptographic protocol, which is a two-party commit reveal. So if you're familiar with this protocol, it's a system where two people can work together to generate a random number. And neither party has to trust the other party in order to prove that the result was fair. So as long as I do my part of the protocol correctly, I know that the result is random, and it doesn't matter what the other guy does. And so this is a very simple protocol, actually. It's sort of embarrassingly simple if I told you how it actually worked. But it's actually very effective on the blockchain because it's very cheap. It just uses hashing, and it can be done very fast. So this has been this is sort of a newer product for us, but it's actually already powering a bunch of different applications. Finally, the third thing that we've just launched is a product in the MEV space. So I'm sure most of you are familiar with MEV, or maximal extractable value. For those of you who are not, MEV refers to the value that validators or miners can extract from the network by reordering transactions. So on any blockchain, there will be transactions that are valuable. whether it's a lending liquidation or arbitraging an AMM pool, there will be transactions that are inherently permissionless, and whoever does them first gets some money. And because the miners or the validators have the ability to choose who gets that money, what ends up happening is they end up, earning all of this value, right? So if you're familiar with flash bots or these kinds of auctions, those are the mechanisms by which the miners end up earning all of this MEV. And I think MEV is a really serious problem to think about in DeFi, because if you think about MEV from the perspective of a DeFi application, MEV is a cost. That money is coming from the users of the protocol. It's coming from the person who lent the funds. It's coming from the LPs in the AMM pool. And what that means is it means that DeFi applications will not be able to have the same efficient pricing as their TradFi analogs, right? They're effectively paying an added cost to MEV when the TradFi versions are not. So in order to really be competitive with TradFi, we need to think about ways to get rid of MEV or minimize MEV. And so we were thinking about this problem, and what we realized is that there are a number of different kinds of MEV, but one major class of MEV basically comes down to the fact that applications don't have a way to get efficient market prices for transactions that they want to perform. So a lending protocol would be a canonical example of this, where you have some collateral that you want to liquidate in order to repay your loan. So you want to sell some Ethereum, get some USDC. The way that lending protocols do this today is they offer a bonus. So they say, I will sell you this Ethereum at a 5% discount, and whoever gets it first gets that money. But the problem with this is that in reality, you could pay much less than 5% and still have someone do this operation, right? There are searchers out there who would do it for 25 basis points, probably less than that. And so all of that remaining money, all of that 4.75%, ends up becoming MEV that's just lost from the protocol. And so when we thought about this problem, what we realized is that if these protocols could just get efficient market pricing for the transactions they wanted to do, this MEV would simply go away. And so what we've created is this product called Express Relay, which we're calling a priority auction. And what this is it's a composable primitive that you can integrate into any other protocol, where you can basically add one line of code and say, I want this transaction to be auctioned off. And then the protocol will auction it off to a network of searchers. We have some of the top searchers in the world, like Wintermute, participating in Express Relay, and they will bid on that transaction. And all of the money from that process will go back to the protocol. And you can transmit it back to your users, perhaps the person who loaned the collateral, or whatever you want to do with it. And so this actually eliminates MEV. It eliminates that whole leakage of value from the DeFi ecosystem. Okay, so I want to talk a little bit about some of the ways that we can see how these kinds of infrastructure are really powering new types of applications. And so one of the trends that I think probably most of you have seen is there's been a lot of perps protocols created recently. Like over the past 2 years, there've been probably 100, I don't know. And that trend is actually under the hood. It's actually partly because of better Oracle infrastructure. So Pyth launched, our initial version of the product was on Solana. We launched it in 2021. But we launched a version for EVM and other blockchains at the beginning of last year. And this is basically right before the rise of perps. And if you look at the protocols that have been built today, 60% of the derivative protocols in existence use Pyth oracles. And the reason for this is that before you had this high frequency, low latency market data, it was basically impossible to build a derivative protocol. If you have an oracle that updates every 10 minutes, there is no way that you can use that to mark somebody's trade. It's not going to work, right? So the availability of this better pricing infrastructure is kind of the secret sauce under the hood of the rise of a lot of these derivatives protocols. So this is really cool, but the thing I want to say is, even though we're improving, oh, I don't know why this slide's here. Hold on. Even though we are improving the state of infrastructure, we've now made it possible. Sorry, this is a graph that shows the total transaction volume on crypto derivatives, and it shows. I don't know if you can see that line, but there's a line there, and below that it's sort of DeFi, and above that it's kind of TradFi, or centralized exchanges. And with better infrastructure, we've made it possible for DeFi to even have a non-zero value here, and it's growing quickly. But you can see that there's still a ways to go to compete with TradFi, right? The volumes that are being done on DeFi are almost nothing compared to the centralized exchanges today. So there's still work to do to improve this infrastructure to the point where DeFi can really compete with TradFi. And that's basically what we're doing at Pyth. We're working to continue to improve the infrastructure to ensure that DeFi doesn't suck. So that's what we're doing. That's my talk. Thank you so much for your time. If you're interested in chatting, I'll be around today and tomorrow. Just come and say hi.